For question number 3, we have an air to be preheated by the hot exhaust gases in cross-flow section. So this is a heat exchanger. So before it's entered the furnace, so the air is preheated. So you have a preheated air here. Okay, so the gas is flowing through this piping system, or just okay, or sometimes we call it a piping or something. Okay, right. So air enter at heat exchanger at 95 kilopascal and 220 degrees Celsius at a rate of 0.5 meter per meter cube per second. Okay, so the compressor gas enter at 100 degrees. So we have a gas throughout this piping system. Okay, there are about, in here illustrated by 5 at 0.95 kilogram per second and live at a temperature of 100 degree Celsius. So they live at 100 degree Celsius. They enter at 180 degree Celsius. The combustion gas enter at 100 degree Celsius. So T1 is for the gas is 100 degree Celsius. At a flow rate of 0.95, live at 100 degrees Celsius. So one enter at 180, live at 100 degree Celsius. So determine the rate of heat transfer to the air. Okay, so the energy balance equation. So this one is quite interesting. So some will ask you why, where there is no kinetic energy or this thing, gravitational effect, which is normally related to the potential energy. So just leave it this one. So if you look again to this equation, right? Okay, we have heat in, so there is Q here. So there's the Q. There is no effect of work, so there will be no work, no work out, so no Q out. Okay, and there is no effect of kinetic energy and potential energy, and leave Q1 MH1 and MH2 in and outlet. So that's why we have the final equation is this one. Okay, so from a very long equation, okay, so E minus E out, so we don't have the effects of W, we have this one. We don't have no effect of gravitational effect and this kinetic energy, so no this one, so leave with Q in and M1 H1. Okay, and we don't have no effect of heat leaving and work generated, so we have M dot H out. So out is what? 2, in M2 2, so this one in is 1. So because there is only one flow in and one flow out, so there is one straight, so only in and out, so that's why M dot equals to M1 dot equals to M2 dot, because there is only one way in and one way out. At different, you might say there is a lot of piping here. No, where there is a 100 piping, if there is one flow in and one out, then it's still equivalent to the same amount of flow rate for all the item. And if not, then the things will explode. Right, so rearrange the equation, MH1 minus H2. So again, remember that when it is ideal gas, instead of H2 minus H1, we can use CpT2 minus T1. Okay, so that's why we use CpT2 minus T1. Okay, now you might be asking, why don't we convert into Kelvin or not? So even if you convert into Kelvin, the same 180 plus 273 minus 100 plus 273. So still the value of 180 plus 273 minus 100 plus 273 is still same as 180 minus 100. So it's still 80. So both are way. Okay. So but also this one they say what? Degree Celsius. So just use degree Celsius. Okay. So you got 83.6 kilowatt. So now mass flow rate of the air. So again we can use the ideal gas equation, PV equals to MRT. Okay, small v, so V PV equals to RT. M is what? M is 0.5 meter cube per second. Okay, and then 0.5 meter cube per second. So because there is dot here, also there is dot here. So the only difference is what? Per second. If you don't put the kilogram per second, then there is no second here. So that is the only difference. Remember that if you put dot here, this one also dot. Okay, that's mean rate per second. So 0.287 divided by 293. So this one have to plus 273. Why? Because R is 0.287 kilogram per, as used in the previous question, is one kilogram per meter cube, kilopascal per meter cube per kilogram dot K Kelvin. So this one have to be in Kelvin. So it's about 0.75649. Okay, so for the outlet temperature of the air, so because this is heat equal what? mCp T out minus T in. So rearrange the equation. 30 degrees Celsius plus 83.6, which can be calculated before, over m dot 0.567 over 1.005. You might be wondering, why don't we convert into watt? Because this one is K, so K is K, so that's why we maintain 83.6 kilowatt. So watch out for the units, otherwise you got a different answer. Okay, so TR equals to 167.3. Another thing is that, let's say this 180 coming in, 100 degrees Celsius out. So the temperature should be, the question answer should be between this 100 and 180. So let's say if you forgot to convert, or you just directly convert into watt, then you got a value of 1673. That means your answer is wrong. Okay, so that's one of the way that we want to check out our answer is correct or not. So if you have the temperature is too high, let's say 1000 something, that's mean you can say that you found some error, which is now you have already converted into 83.66 times 10 power of 3 watts. So you put here is 10 power of 3. So you got the value is very, very high. So logic sequence is that it should be less than 80 degrees Celsius. So that is one of way that we try to check our value of answer that we answer and we written in the exam question. Right?